everybody, my name is Abunawaz Bear from Mirror Science Lab, and today we are going to be taking the Practice AMC 12 2009A. This is the most recent AMC I haven't taken. Alright, problem 1. Oh gosh, I'm scared. Kim's flight took off from Newark at 10:34 p.m. and landed in Miami at 1:18 p.m. Both cities are in the same time zone. If her flight took 8 hours and m minutes with zeros less than m is less than 60. What is 8 plus m? Oh, that's easy. Okay, so 10:34 to 1:18. Well, after 2 hours, it would be 12:34. And so that's 2 hours. And then after 26 more minutes, it would be 1 o'clock. And then after 18 more minutes, he would have landed. So that means the amount of minutes is 26 plus 18, which is 44. So that means that the sum should be 46. So let's put our answers over here. Over 1 plus 1 over 1 plus 1. 1 plus 1 is 2. So 1 over 1 plus 3 over 2. It's 1 plus 2 thirds. This is 3 thirds, so it's 5 thirds. So it's C. Well, what number is 1/3 of the way from 1/4 to 3/4? Well, just 3/4 minus 1/4 times 1/3 plus 1/4. So this is 1/2, I think. Yeah, it's 1/2. So it's 1/6 plus 1/4. It should be 5/12, I think, but doesn't hurt to check. 2/12 plus 3/12. Yep, it's 5/12, which means the correct answer is B. Okay, 4. 4 coins are picked out of a piggy bank that contains a collection of pennies, nickels, dimes, and quarters. Which of the following could not be the total value of the 4 coins in cents? Alright, well, let's think. 15. So how can you get 15? Well, you could have... I don't think 15 is possible. You can obviously get it with 3 nickels, 1 dime, and 1 nickel. But I don't think you can get it with 4 coins in total. So it's probably A. Good. 5. One dimension of a cube is increased by 1, another is decreased by 1, and the third is left unchanged. The volume of the new rectangular solid is 5 less than that of the cube. What was the volume of the cube? So if we have x cubed is equal to x plus 1 times x minus 1 times x plus 5. So x cubed is equal to, well, what happens if I distribute? We get x squared minus 1 times x plus 5. So we get x cubed minus x plus 5. What? Oh, God. Plus 5. So now this becomes pretty tidy. X equals 5. So the volume was 125. 6. So P is 2m and Q is 3n. 3 to the m. Which of the following is equal to 12 to the mn for any pair of integers? Well, 12 is equal to 2 to the 2 times 3, right? So 12 mn is equal to 4 to the mn, or 2 to the 2 mn times 3 to the mn. So, yeah, it's probably D. No, it's E. Yeah, it's E. Because 2 to the 2mn plus 3 to the mn times 3 to the mn. P is 2 to the m. So this is just P to the 2n times Q is just 3 to the n. So it's just Q to the m. Yup, it's E. Alright. Oh, okay. The first 3 terms of an arithmetic sequence, so adding, are 2x, 2x minus 3, 5x minus 11, and 3x plus 1, respectively. The nth term of the sequence is 2009. What is n? Alright, so that should be pretty easy. Arithmetic means we have one common difference. So minus 5x plus 11 is equal to 5x minus 11 minus 2x plus 3. So That means we have minus 12 minus 2x is equal to 3x minus 8. So 5x is equal to 20 and x is 4. So that means that the first three terms are 5, 9, and 13. So that means that the common difference is 4. So first, second, third. So we can determine a recursive formula for the nth term, which should be 4 times n. Okay, so 4 times n plus 5. Well, 3 times n. Wait, no. 4 to the n times n minus 1 plus 5. So 4n minus 4 plus 5. So 4n plus 1. So that's for any nth term. So 4n plus 1 is 2009. 4n is 2008. So n is equal to, I believe, 502. Yeah, B. Okay. And where's our answers? 7B. Okay. 8. 4 congruent rectangles were placed as shown. The area of the outer square is 4 times that of the inner square. What is the ratio of the length of the longer side of each rectangle to the length of its shorter side? If you don't know, folks, if you have just joined, we're doing an AMC marathon. We're seeing how many I can solve in a row until I just become clueless. So the area of the outer square, So the area of the outer square, so let's say this is S, is 4 times that of the inner square. So that means that the side length of the inner square has got to be half S, right? And then we've got these fellows. I think, yeah, it looks like that. So then, what do we have here? Well, we have half S, fourth S. Okay. What is the ratio of the longer side to its shorter side? So this is 3/4, and this is 1/4. So longer to shorter should be 3, which is A. Okay, so now f of x plus 3 equals 3x squared plus 7x plus 4. Ax squared, f of x is ax squared plus bx plus c. What is a plus b plus c? Alright, that shouldn't be too bad. Oh wait, I should erase this. Okay, so x plus 3. So a times x plus 3 squared, b times x plus 3 plus c equals 3x squared plus 7x plus 4. Alright, so we have a times x squared plus 6x plus 9. You should get a chair for yourself. And then bx plus 3b plus c, 3x squared plus 7x plus 4. Alright, so ax squared plus 6ax plus 9 plus bx plus 3b plus c, plus 9a, oops, is equal to 3x squared plus 7x plus 4. Alright, so we already know 9a plus 3b plus c, that is equal to 4. We know a is equal to 3, so that means 27 plus 3b plus c equals 4. So 3b plus c is negative 23, I think. Let's see, what else do we have? Oh yeah, we have the info that 6a plus b is equal to 7. So since we know a is 3, 18 plus b is 7, so b is negative 11. So that means 3b is going to be minus 33. C minus 33 is 4, so C is 37. So we have A being 3, B being negative 11, and C being 37. which means in total we have negative 8 plus 37, which should be, what's 37 minus 8? 29? Oh, okay. So, we've done something wrong somewhere, which is good. That's good. So, let's see what we've done wrong here. 6a plus b, 3b plus c. Okay, let's see. From what I'm getting, it looks like it should be 3x squared plus 3x squared plus or minus 11x plus 37. So does that work for x plus 3? Well, if we plug in 1, you get 3 minus 11 plus 37. Okay, so let's plug in 4 to this function. And if we and whatever we get should be the same as what happens when we plug in 1 here. So if I plug in 4, we get 3 times 16 is 48 minus 44 plus 37, 41. But the other one, I only get 14. Okay, I've identified that I have indeed made a mistake. Now I need to identify where I have made a mistake. So let's see. Ax squared plus 6ax plus 9a. So a should be 3, right? Right? So 6a plus b is 7. 18 plus b is 7. B is negative 11. Oh, no. That's not right. Oh, I see where I made a mistake. So 27 minus 33 plus c equals 4. So what's 27 minus 33 again? I think it's 6. Minus 6. C is 10. So what I'm getting here is it's 3 minus 11 plus 10, which is 2. Good. So it's D. It's D. Okay. 10. It's 5. Oh, I should probably erase the work for the previous one. Erase. Okay. Getting back to it. In quadrilateral ABCD, AB equals 5, BC equals 17, CD equals 5, and DA equals 9. BD is an integer. What is BD? Alright, let's draw this out. Obviously, I can't interact with the diagram on that web page. Okay, let's draw CB as a straight line first. CB. Then we have D, which looks something like that. Then it curves up slightly. Yeah, that's a very slight curve to A. Then goes back down pretty quickly to B. We know this is an integer. And let's write what we know. 5, 17, 5, 9, x. Okay. So let's see. What can we do? Oh, we could try using the law of cosines. That should work. So, but the law of cosines, we don't know the angle. Well, let's try. So we know x squared is equal to 25. I'm really exercising hard there. 81. Oh, minus 2ab. So 90 cosine x. Well, not x in specific, cosine theta in general. And this has to be some integer. So the largest this can be is obviously 90. So x squared is equal to 106 minus 90 cosine theta. So if it was 0, then I could say, oh no. But nope, it's not 0. So we know, okay. So what do we have as our possibilities? Well, we have 25, 36. We need everything. 49, 64. Oh my god. 64, 81, 100. Okay. Aha. And I do know that when we add it to 5, it should exceed 17. So, let's see. Oh, I just realized cosine can be negative. So, well, I'm going to have to write out everything till 196, which thankfully isn't a lot. We have 121, 144, 169, and 196. Now, anything below 12 gets eliminated because when we add this to 5, it better exceed 17 because, that's how triangles work. So we have 3 possible values, 12, 13, or 14 for x, which are exactly B, C, and D. Wow, that is very good luck. Okay. So, let's see. What else can we do? Oh, well, it has to be less than 5 and 9 when combined. So it can't be 196. So x is not 14, so it's either 12 or 13, but I don't want to have to guess. So let's see if we can narrow it down just a bit further. So let's use this. So it's either 12 or 13, right? Alright, so let's test both cases. So we have 5. Let's say this is 12 and this overall is 17, right? Okay. So now what I can do is I can say, oh my god, it's so tricky to do this without a right triangle. Ooh, okay. So I think, do those still have to be similar? I don't think so. So, this is x, y, this is z. Plus y is 17. X plus so z squared is 25. Y squared plus z squared is equal to 144. And let's see, what other information do we even have? We're really left to think. Okay, so let's also try with this one. We can test it to be either 12 or 13. So if this is 12, we know this has got to be 9 and this has got to be 5. Can we have some possible triangles like this? Is this possible? Well, let's use the law of cosines to find out. 144 is equal to 25 plus 81, 106 minus 90 cosine theta. So 144 minus 106 is 44 minus 6, which is 38. So minus 38 over 90, which would imply this is an obtuse. What about 169? 169 minus 106 is 63. Minus 63 over 90 is equal to minus 63 over 90. Let's draw something like this. and we're trying to find cosine theta. So that's the x-coordinate. So it's either minus 38 over 90, which looks something like, if this is 1/2, then minus 38 over 90, this is minus 1/2. Minus 63 over 90 is going to be a little bit farther. I can simplify that into minus 21 over 30. It's going to simplify even further into minus 7/10. So minus 63 over 90 we have over here. Is minus 7/10, it's a little bit more, well, no, a little bit less than 135 degrees. This look like, yeah, I think so. Well, this is barely breaking 120. So I am going to wager, just from the diagram, even though it might not be drawn to scale, C. It's either B or C. I'd be very sad if it's B. The figures F1, F2, F3, and F4 are shown are the first in a sequence of figures. For n is greater than or equal to 3, Fn is constructed from Fn minus 1 by surrounding it with a square and placing one more diamond on each side of the new square. Then Fn minus 1 had on each side of its outside square. For example, figure F3 has 13 diamonds. Does it really? Oh yeah, it does. So how many diamonds are there in figure F20? Okay, it wants me to derive the sum of squares formula. I do not want to derive the sum of squares formula. How many is this? 1, 2, 3, 4, 5, 6, 7, 8. This is 1, 2, 3, 4. Okay. So, 1 progressing to 4, progressing to 8, progressing to, what is it here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And, okay, how many are going to get, that is a really weird pattern. It almost feels like I can formalize it somehow. So the sum goes from 1 to 5 to 13 to 25. Okay, so let's see. So each new one is going to add 4 plus, in figure F4, there were 2 on each side. So n minus 2 times 4. So 4 times n minus 1 diamonds are going to be added each time. So yeah, that's right. Right? Well, for F2, we're adding 4 new. Aha. 0, 4, 8, 12. Okay, so we're adding 4s. So we're adding all of the multiples of 4. So this is figure 1, F2, 3, F4. So F20 is presumably going to be 19 times 4. So we're summing up probably all numbers from 1 to 19. So let's use Gauss's formula and multiplying that by 4. Well, 190 times 4. And that should be equal to 380, 760. 761 because of this fella over here, this little diamond. So, let's see. Is there anything wrong that I've done? I don't think so. Let's try summing up everything from here and then counting the total amount here. So using our formula, we should get, we're summing up all numbers from 0 to 3. So 3 times 4 over 2 times 4. So that's 24. And summing up all the numbers here, we do indeed find that it's 24. So that means that 761 should be the right answer for 11. Wow. We're going on to 12. How many positive integers less than 1,000 are 6 times the sum of their digits? Oh boy. Oh boy. Okay. Well, we first have the case of the 1-digit numbers, which only have 1 digit, so we're not considering them. So we have the 2-digit numbers and the 3-digit numbers, because 4 digits are off limits. It's less than 1,000. So how many positive integers less than 1,000 are 6 times the sum of their digits? So if we have 10